Hi. We completed all basics. Okay. Today we will see Snowflake architecture. This is very important to understand how Snowflake will work. Okay. What are the components are available? Okay. Let's go through this Snowflake architecture. Before starting Snowflake actual architecture, we will try to understand what is shared disk architecture and shared nothing architecture. Here observe we have multiple compute instances. Okay. Here only one database. Okay. This is shared disk. This disk is shared by multiple compute resources. Okay. Shared nothing architecture. See, here is a database. Okay. Database, database, database. So with each database, okay, is accessed by the only one compute resource. Okay. Here we have only one instance. So this is individual. We are not sharing anything. See this machine. If you want to get the data from here, not possible. Okay, this machine want to get data from this one, not possible. Why? Because this is very tightly coupled with okay this database and this compute resource. Okay, so if you use this shared disk architecture, okay, so we have some disadvantages like single point of failure. If anything happens to this database, okay, no one will access anything here. That is a problem. But here somewhat better. If anything happens to this one, at least these will work. Okay. But here's again one more problem like latency. As multiple people, okay, from the multiple compute resources, okay, hitting the same database, obviously time will take. Okay. Compute resource means compute in the sense simply assume one computer. Okay. Obviously time will take. Here one compute resource, one database. Okay, we don't feel this latency problem. Okay, the problem is here is scalability is the problem. Okay, limited scalability. Okay, here also we can easily scale, but this one also limited. Okay, so these are the problems. Okay, the problem is latency. Here is the latency problem. Okay, here is tightly coupled. Now try to understand Snowflake architecture. This Snowflake architecture is combination of two. Combination of two. Let's see how it will work. So using this architecture, this Snowflake architecture is multi-cluster shared data architecture. Let's see what is multi-cluster and what is shared data architecture. Here observe, we have three layers in the Snowflake. One is cloud service layer, one is query process layer, one is data storage layer. We have another names also for this layer. We will see later. Now this is a query process layer. Now in cloud service layer, okay, query process layer, data storage layer. Okay, this one is the main services. Like how it will act is like it will control everything. Like any person, okay, trying to access our Snowflake account. Okay, first it will authenticate. Okay, first it will authenticate. If you are running, if you are utilizing any virtual warehouse, if you are utilizing any virtual warehouse, okay, so before like we will configure our virtual warehouse. Okay, means we will create we'll create one virtual warehouse like prod. So we created one virtual warehouse. We will see how we can create our virtual warehouse. Okay, maybe uh, at the time you'll understand more, but now understand we are creating one virtual warehouse with some medium size. Okay, assume we are creating one computer. Okay, assume we are creating one computer to execute our queries. We will write all SQL queries, right? Execute our queries. Okay, so this information will maintain here infrastructure. Okay, based on that only the moment, okay, we select this warehouse. Okay, based on our based on our configuration. Okay, so we will get that machine. Okay, that information where and all where we are maintaining infrastructure manager in cloud service. Okay, we execute query, right? The query will optimize here. We have optimizer here also. So query in sense simple still. Initial SQL statement. SQL statement. Okay. Now transaction manager. So in real time, not it's not like a single person only query the data, right? From these databases, okay? Not a single person will query always, right? We have so many people, right? So many users will keep on hit the SQL statements, right? So each transaction, okay, from each user, okay, it should be maintained accordingly, right? So this transaction manager will take care. And metadata. So whatever we create, okay, all these objects related information, okay, will be available here. So we'll maintain here. So overall, this cloud service means it will take care all this, okay, infrastructure and optimizer and transaction manager related and security, okay, and metadata. Mainly, the first thing is access. So all these things, okay, will take a cloud service. In query process, what happens? Actual queries will execute. Actual queries will execute. The moment you submit, from where you will submit, you will get one editor, right? Worksheet you will get. Okay. Further, I will show you. Okay. Once you log into the Snowflake account, okay, you open any worksheet, okay. So here in the worksheet, you will write the queries. Okay. Here you will write the query. Okay. And you are selecting here, see, this is the virtual warehouse. Okay. So this is nothing but assume. Okay. On compute. Okay. Compute in the sense on compute assume. Okay. In real time, in Snowflake environment, this is virtual warehouse. Okay. How it will behave virtual warehouse internally, I will explain later. Okay. Assume for time being just on computer. Okay. To run our queries. Okay. So once you execute any queries from here, okay, the queries will go to virtual warehouse will take, okay, all these queries and get the data. So from the worksheet, whatever you trigger any query, okay, it will go to virtual warehouse. Okay, the virtual warehouse will run those queries and will get data from respective database. Okay, then it will give result back. Okay. Now the third layer is storage layer. Okay. So here compute missions where our queries will execute. Okay. These queries from where data will come from the storage layer. That is data storage. Okay. Now how many virtual warehouses we can create? There is no limit. There is, so based on our requirement, okay, we can create virtual warehouse. Here, if you observe or not, by default we got one compute warehouse. That is this one. This one is a compute warehouse. By default, the moment we create account, right, we got this warehouse with size is X small. Okay. So next session we'll create our own virtual warehouses. Okay. There we'll understand more regarding. Okay. Now, so I don't want to suppose I'm creating one virtual warehouse. I don't want to create here one more database. It's not like that. Okay. Wherever required our virtual warehouse, we can create, keep on. Okay. Wherever required our databases, I can create, keep on. There is no link between, okay, this query process, okay, data storage. Okay. So this is not, see, decoupled. Decoupled means there is no link. Okay. Means something we are adding one compute resource. I want to add one database means no, not required. Okay. So these things will scale. Okay. Means we can increase or decrease. Okay. Virtual warehouses. So that is our base based on. Okay. Here databases. Okay. Based on our applications. Okay. We can increase. If anything we don't want means we can decrease. Okay. So compute and storage. Compute means this one storage. Sorry. Compute means this query process. Okay. And storage. This one scale them independently. Okay. There is no dependency. Okay. That's what it's meaning. Multi-cluster shared data architecture means the I have one more virtual warehouse. Assume ETL virtual warehouse. Okay. I have two warehouses. This one something, some other report warehouse. Assume report warehouse. Assume. So this compute, okay, can access data from any database. This warehouse also can access this database. This warehouse also access this. Okay, there is no restriction that so and so virtual warehouse can access only this database. No, only thing is we need to give permission to this virtual warehouse, okay, to run, okay, accordingly. So this is overall, okay. So uh, this is overall regarding these three layers. We will see different point for each, okay, layer: cloud service layer, query process, and storage. Yeah, cloud service layer. Whatever we discussed, right? I kept as a points. Okay. See, it will handle authentication, access control. Okay. Means I have one Snowflake account. I'm just repeating points. I have Snowflake account. Okay. I have multiple databases here. I have multiple databases here. Okay. So any person is trying to access, assume multiple persons are there, trying to access Snowflake account. How they can access? Maybe using the UI. I told right how to connect the Snowflake account. We have multiple ways, right? UI, okay, Snowside, or I can use any programming like Python, okay, Java, anything, okay, SnowSQL, SnowSQL, okay. I can use any driver or diary, any, okay. So Snowflake provided, okay, way. So I will give my username and password, okay, to connect. So initially in which layer authentication will happen? Okay, in cloud service layer, there is our one service, okay, authentication access control, okay, that it will check whether this is person is available or not. Okay, infrastructure management, as I told, right, virtual warehouses, okay, how to how we configure based on that, okay, we'll get that compute provision. Means we'll get transaction management and metadata management. So metadata management means all objects related information and also contains some, okay. Take one example, EMP table. Okay, we have one column salary. Okay, what is the sum of this salary? Okay, so that sum related. Okay, as a metadata, the data is available. Okay, here how it will maintain means, okay, we have like columnar mechanism, okay, how data will store mean in the Snowflake, okay, in the columnar format. We'll discuss down the line, okay. So some aggregations related information, some aggregations related information available in the metadata, okay. Some table structures, okay, we'll create the table, right. Table means we are defining the definition, right, with all the columns. That is nothing but, okay, the metadata. Okay. So that metadata information, everything available. Okay. Query processing and optimization. So obviously, the moment you run the query, okay, internally Snowflake, right? So it will pass the query and optimize accordingly. Okay. Obviously, security. Okay. Security in the sense, okay, encrypting. Okay. Any sensitive data automatically, not sensitive data. By default, it will encrypt all the data. Snowflake. Okay. So to run these services, right? Whatever the service, okay, this is like this cloud service layer should be run somewhere else, right? Okay, where it will run, okay. This layer also runs on cloud computing like virtual warehouse, okay. To run this service also, we need one computer, right? We need one server, okay. Ideally, computer in the sense like one server, okay. Assume server in the sense just in your normal language, assume one computer, okay. But normal computer will have very less, okay, storage and, okay, and process, right. But server means will have the more storage and more power to process the data, okay. This means high configuration, okay. So server, node, okay, all are same, okay, with big configuration, okay. In for our practicing purpose, whatever the software is, where we will install our computer, right. Okay, in real time, all the softwares where they will host, install, host, both are the same. Okay, don't confuse. Install or host means just, okay, any software how they will host means on top of the servers. Okay, on top of the nodes. No, see what this compute service layer where it will run, ideally one virtual warehouse. Okay, means whatever the virtual warehouse what I'm talking about here, right? This virtual warehouse, nothing but one computer, right? I told. Okay. The same way to run this. To run this compute layer also, we need one computer. Okay, that one also will run on the cloud only. Okay, how that mechanism will work means internally Snowflake will maintain. Okay, they are owners of this software, right? Okay, where this software should run. Okay, they will take care. Okay, user and session manager. I told that each user. Okay, the moment you connect with the user, okay, that session will create, right? Okay, that everything will maintain by the cloud service. Okay, manages all the services like snow, pipe, task, materializes, everything. Okay, we have separate sessions for this one. What are the snow pipe? What is the task? What is the materializes? Okay, down the line. Okay, everything will discuss. Okay, this required. Okay, whatever the serverless. Okay, mechanism. Okay, everything will maintain by the cloud service layer. This layer completely independent of the storage as I told. Okay, this layer is completely independent. As I told, these two are independent, right? And this one also independent. Manage, maintain life cycle of the query. Okay, means the moment you, the moment any person, okay, once authenticated happened in the worksheet, okay, query can run, query can hit, right? The entire history will be captured in the cloud server. Okay, in the query history tab we have. Okay, we will walk through all. There we can maintain everything. Okay, authentication authorization can access control uh, everything. Authentication access, right? Whatever I'm talking about, this entire, right? Once authentic access is available or not. Okay, how we are authenticating, right? It's okay. If you connect anyway, okay, it will happen. Okay, MFA is like just a token, it will multi-factor authentication means we'll get, right. We are trying to log in any account. Okay, we'll get if you install respective app in our mobile, it will get one notification whether you are not. Please click in Google. Will get, right. Once you're trying to log in Gmail, okay, if you configure, okay, then you will get alert. Please, if you are, please enter yes and enter number like that. Okay, this is multi-factor authentication. We need to accept from our mobile. Okay, once we configure to our account. Okay, as I told, query parsing optimization. Okay, and infrastructure and metadata management. Okay, everything. Okay, so whatever we have few topics I kept kept here. Here we have few topics: zero copy cloning, time travel, okay, data sharing, okay, everything. Okay, we will discuss, okay, as a separate topics. Okay, yes, whatever I mentioned right here, all are separate topics. Here also, snowflake, task, materializes, and here zero copy cloning, time travel, data sharing. Okay, so while explaining these topics, you'll come to know, okay, what exactly, okay, how uh, this is associated with this cloud service layer. Okay, all these topics. Okay, query process layer. See, we can we can call this one compute layer, query process layer, or just processing unit. Okay, as I told, query process layer. Just I'm repeating. Okay, query process consists virtual warehouse to process the query. It's all. Okay, whatever the queries. Okay, you are you are triggering from the worksheet. Okay, where it will go? It will come to virtual warehouse. This virtual warehouse will take data, required data from the this storage, and it will process and it will give back to the user. Okay, that's the process. If you go to UI, what happens? Whatever you write here, write the queries. The moment you write the query, and if you hit here, okay, the respect to virtual, okay, warehouse will run and all process. The moment you try to insert the data, okay, update the data, and again selecting the data, everything, okay. At the end, we will see one example, okay, we'll come to know. Virtual warehouse is named as such. So virtual warehouse is just we are giving one name. That's it for the compute instance. See, compute instance, okay, or server, can node, okay. You can everything is same. Underlying virtual machines are EC2, Azure Virtual Machine, GCP. What means whatever you are talking about compute resource, right? Okay, who will provide? Assume while creating the Snowflake account, okay, initially we have three options, right? One is Azure, one is GCP, one is AWS, right? Okay, so we opt AWS, right? While creating our Snowflake account, okay, means indirectly who will provide compute resource? AWS will. Okay, means the moment we create virtual warehouses, okay, the moment we create virtual warehouses, okay, how okay, resources will provision by the AWS. How they will giving, okay, indirectly computers means is EC2, okay, AWS is giving EC2 in the backend. Backend they are giving, okay, AWS is providing a service, okay, means I want one computer. If I ask AWS, I want one computer means simply what they will give. They will give, okay, this EC2 service. Simply EC2 nothing but, okay, they will give computers to process the data. Okay, so Snowflake not having any infrastructure. Snowflake is just a software how to organize the data in the database. That's it. Okay, so to interact with or to organize this data, entire thing, to process this data, okay, we are depending on the third party provider. Means Snowflake is depending on third party provider, okay, Azure or GCP or AWS. So while creating the account itself, we will choose which cloud provider, okay, we can consider, okay. So in the cloud computing session, okay, I explained, right? So here this guy is providing one service, that is compute service. I want one computer means they will give the EC2. Okay, simply virtual warehouse whatever I'm using, indirectly who is providing that compute service? AWS for my account. Okay, what service they are providing? EC2. EC2 is nothing but just like a server, Azure lab or a computer. Use it to process our queries. Okay, now virtual warehouses can be created, removed instantly, and suspend. Okay, and the default 10 minutes resume. Okay, so this virtual warehouses, okay, how many I can create? I can create based on our requirement, one, two, three, or whenever required only I will use. If computer is not required, I can suspend. Okay, any computer any compute is not required, I can remove it. Okay. So it is very flexible. Default 10 minutes is nothing but suppose I have one virtual warehouse, okay. I trigger some queries. Query 1, query 2, query 3. This virtual warehouse will up and run. Okay. Then after that I didn't provide any queries to this virtual warehouse. Okay. Then what it will do? It will wait 10 minutes. After that, no queries means there is no work to do. Means indirectly it will go to okay shutdown mode. Means it suspend automatically. This virtual warehouse is suspend automatically. Indirectly, this EC2 instance will go down automatically. That is by default 10 minutes. Okay. Number of virtual warehouses with their own configuration. Okay, based on it means indirectly you have this is one virtual warehouse, this is virtual warehouse, this is virtual warehouse. Okay, here this configuration can be different. Maybe this size medium and clusters 3. Assume this size is small, clusters 2. This size is like large. Okay, clusters 10. Okay, so max is 10 only. Okay, so I can create with max means it's not like each virtual warehouse can contain same configuration. So based on our requirement, we can create. Okay, that's the meaning. Okay, so we can create n number of virtual warehouses with different configuration. Okay, based on our need. Okay, cost will be calculated based on the number of queries, execution time, virtual warehouse, minimum billing. Okay, so any virtual warehouse. Okay, it will up and down means the default okay billing is per 1 minute, even though 1 minute, right? 60 seconds. If you run that one 36 33 seconds also, but default billing is 1 minute. Okay, so initial the first minute. Okay, it will first time. Okay, if you started your virtual warehouse, okay, after 33 seconds, okay, again your shutdown. uh, Assume you did shutdown immediately. If shutdown means indirectly suspend. Okay. So if you do within the 30, within the 60 seconds, like that, okay, at the 33 second, okay, you suspended that virtual warehouse means even though you have to pay 1 minute. Okay, that is minimum billing. So cost, right? Entirely, it's depending upon the size. It depending upon the size. If you choose small, if you choose okay large, if you choose medium, okay, based on that size, okay, they will they will be different charges. Okay, so in the next okay in this virtual warehouse concept, we will see how charges will be. Okay, here here. So how they will charge means based on the credit. Okay, how many we how many hours we use that virtual warehouse and okay, so based on that, right, they will do cost calculation. Okay, for month we need to pay accordingly. Okay, we will see in depth in this session virtual warehouse. So all the virtual warehouse have the consistent access to the same data in the storage layer. It mean any warehouse you take, okay, having the same consistent access, okay, to this database. Okay, it's not like there is no restriction at all. Okay, until unless we provide manually restriction. Okay, scale up down as needed. immediately. See, scale up down immediately in the sense, assume one person, okay, running virtual warehouse. Okay, how we will run? We have worksheet, right? See, any person, I'm running all the queries. This virtual warehouse will run. Okay, I want assume this x small is not enough. This x small is not enough. Assume. So I want to move to x small to medium. Then I can move. Here see one more thing. Here I initially I configured medium. I want to change from medium to small. I want to decrease the size small. Yes, I can do anytime. Okay. Here virtual warehouse. Assume this one is small. I want to increase to medium. Okay. I can do however I want. Okay. So those are related to compute layer. Okay. So I'm repeating points. Okay. To make you understand. Okay. Cloud. Uh, this storage layer. This cloud storage layer. Why I'm calling cloud storage layer means it is where it's storing. Okay. Here, while creating the Snowflake account, okay, based on platform you choose, right? AWS. If you choose means where our data will store in S3. Okay. How AWS is providing to run our queries. Okay. Computer as a service that is EC2. The same way to store the data. Okay. AWS will provide service of S3. If we choose GCP, GCP bucket. If you choose Azure, Azure block. Okay. So based on the platform, they have separate service name, but functionality is the same. Whoever provide storage service means to store the data one, right? Okay. Maybe service name different state. Okay. So purpose is same. So here we choose already, right? AWS. So for the virtual warehouse, they will give EC2 to storage where they will store S3. Directly we can go and access this one? No. Why? Because where we are storing the data in S3 from which software? Our database software like Snowflake. So always we need to include we need to interact with okay SQL only. Okay, directly we cannot. Okay. If any files we directly kept in any our S3 location means we we can create our bucket. Okay, we have separate sessions for that one, how to create the bucket, how to create the folder, how to keep the our customer file. Okay, that is different. Okay, whatever the Snowflake internally, okay, storing the data the moment you create the table, the moment you insert the data in the table. Okay, how data will store in the S3, okay, in the columnar format. Okay, we will see what is this one, columnar. Okay, now Snowflake stores all the data in the database. Okay, database is logical group of objects within the Snowflake instance. Okay, so entire database means we see here this database. Okay, all objects contains. Okay, like tables. Okay, views, material views, stages. Okay, file format, whatever the objects are there in the Snowflake, right? Okay, so everything okay logically group means like logically grouping objects within the Snowflake instance. Okay, so logically grouping in the sense I will show you this one. See, if you take this see one example. Okay, so this is database. Okay, this is schema, right? Logical means we have views, right? under this one. Logically we are grouping. Okay, functional. Okay, like this if you take differently, like this is the functions, these are the functions. We have only views. Okay, for each schema there's we can see logically, not physically. These are logical. Okay, we're able to see here tables, views, functions like that. Okay, so main objects like tables only. Okay, we can create table permanent, temporary, transient, and we can create views. Okay, standard and materialized. Okay, everything will practically will create. Okay, we'll play with all these objects. Okay, so here compress whatever the data we are storing in the, okay, in the storage layer, right? Okay, it is compressed, secure, encrypted by default with AS256. Okay, so the moment you are storing the data in the database, right? Okay, it will be compressed. Okay, it encrypted automatically. Okay, as I told, right, based on our cloud provider. Okay, whatever you choose, yeah, right, cloud provider. So underlying, okay, underlying service. Okay, suppose AWS, as I told, right, S3. If you choose like GCP means GCP bucket. If you choose an Azure means backend in Azure will store. So scalable cloud storage. Okay, why scalable means there is no restriction that I can store only 10 GB, only 10 GB data. No. Okay. So based on our the moment you are trying to insert the data, right? It will the AWS will provision, okay, storage capacity. Okay. Here I can store, okay, CSV, semi-structured, okay, all the data in the Snowflake. Okay. You have variant, okay, data type, okay. Using that one, I can store, okay, entire, okay, the uh, CSV file data, okay, and JSON, okay, file. If you have anything, everything I can store, okay. So we have separate practical session. So how we can do this one, okay. There I will explain you, okay. Now this is just overall what are the things, okay, uh, Snowflake having for each, okay, layer. Here data will store in micropattern. This is very very important. Here, the moment you're trying to insert the data in the how data will store. Data will store in the micro partition. Okay. How data will store in columnar form. Okay. Okay. So what is this columnar format means? We have row storage. Yeah. Take any databases. Okay. Data should be stored, right. Okay. They will okay in ideally two ways. Okay, we will store normally row storage, columnar storage. Okay, if you take row storage means Oracle DB, Oracle database, it will store row storage. Okay, our Snowflake, okay, will store data in columnar storage. Okay, what is this mean means row storage means simply take one, we have data like ID, like student ID, okay, name, just assume, okay, student ID 1, 2, 3, 4. This is just a logical representation. The moment you hit the select star from any table, okay, here, whatever if you see, okay, output. Assume we are running one query. Okay, we are getting some output indirectly here. Whatever you see, that is nothing but uh, that is just okay logical representation. Okay, for you, let me create one table. We'll see. Okay, I'm create database. Uh, it's a school. Oh yeah, database is university. See, the moment I create okay database, see here it is change university. Okay, let me replace here. Yeah, see, you are able to see only this new okay database. Okay, earlier these are like sample databases. Who will provide this thing? Okay, the moment you create the account, right? Snowflake will give this saved databases by default. This one we created now. Okay, let me create schema. Okay, now just give college. See, in this database, I created this schema. Okay, let me create one table. Create table, student detail table. Okay, with columns ID, number, name. Okay, I'm taking only two columns only. We have separate sessions for this also. If you don't know SQL, right? I'm inserting insert into details. Okay, just I'm giving values. First number is Akshara. So I'm inserting this record. Okay. I'm inserting another record. Two. Yeah, I have two records. Let's select this data. Okay. Whatever this, right? This is what I'm calling as a logical representation. Actually, this data underlying, okay, how it will store as a columnar. Physically, how it will store as a columnar. Okay. How that columnar means, okay, one Akshara, two Latka, right? If you go here, one, okay, assume Akshara, second one is Latika. Assume two records only. Let's take two only. Okay. This is logical representative. We are able to see, right? Okay. So the moment see what we did from the worksheet. Okay. We created one table and we inserted the data. How data will go? Data will go to in database respective also. This one is college university database also. University which we created assume. So we created one table student detail table, right? So we inserted some data ideally. Okay. The physical how data will store in the columnar format in this database in the micro partition will store two records. Okay. Two records in the micro partition as a columnar format it will store physically here physically. Okay, but the moment you write the select statement how data will come as a logically. Okay, whatever you are storing sorry whatever you are able to see right here this is logical representation. Okay, not a physical representation. So physical representation data will store in the columnar format. Okay. So as I told, right, Oracle will store data in the row format, row storage, row storage. Our Snowflake will follow columnar storage. Okay. Row storage in the same take. Okay. Same example. One. Okay. Akshara. Like this entire row will store in the okay underlying database, right? Means indirectly in the hard disk. Okay, it will store. Second, Latika. Okay, like this. Assume just I'm giving logical representation. Okay, just to imagine. Okay, like this it will store. Okay, but columnar means this is nothing but row. Columnar means it will store one, two here only. For entire column data will store one. Okay, here names will store. Sarah, Latika. Okay, here is the ID, here is the name. But here see ID, name, ID, name. Okay, this is the different. Okay, just try to understand. Entire row will store at one place. See, this is the row storage, but columnar means all column information. Assume we have one more record 3, 4, 5. Means 3. Like this it will include. Like this it will include. Okay, just okay. Just imagine the data will store like this. If you use columnar storage. So by default, Snowflake will how it will store the data as form of columnar storage only. Okay, in the micro partition. Okay, so whatever you are able to see, just understand this is logical representation only. Okay, from where it will come data? Data will come from the database. Okay, from the micro. Here. Now, pay only for storage data. Bill is based on the stored data as flat rate is per TB monthly. Okay, how? See, as I told, right, Snowflake not having any infrastructure, that's why we are depending on the AWS or GCP Azure, right? So we are storing some data, means indirectly we are using AWS S3 services, right, to store the data. How the billing happens in the sense, okay? Per DB they will charge, okay? Monthly we need to pay. Means okay, uh, the client will pay, okay? See, I utilizing 10 GB, assume for 10 TB, assume 10 TB data, okay, I store. For the 10 TB only, I will pay. Assume next month, okay, 5 TB only I utilize, okay, I stored some data, means only for 5 TB I will pay. So like that only, okay, this is the flat rate, okay. So storage means in here storage nothing but indirectly our database data where it will store in S3, right? Okay, okay. We need to pay accordingly. Okay, how they will charge means okay for monthly we need to pay as per the TB. Means we normally will get mobile recharge 1 GB data. Okay, 55 rupees, 25 rupees like that we are going to buy, right? Okay, but here is I already using uh, uh, for here, right? I'm just utilizing the space. Okay, later I'm paying. Okay, how much I utilize. Okay, based on that. Okay, Snowflake manages all aspects how data is stored. Okay, means indirectly our Snowflake, right? Our Snowflake. Okay, it maintains everything, how data is stored, okay, like compressed or not, okay, encrypted or not, okay, security, okay, everything, okay, data organization, file size, structure, okay, compressed metadata, statistic, everything will store, okay, automatically. As I told, right, to interact with this data, okay, which we store, okay, where exactly we are storing? As again, I'm repeating, the data is storing indirectly in S3, right? Okay, but can we access that one directly? No, right? No. Only using the SQL only we can interact. That's what this meaning. The data objects stored by the Snowflake are not directly visible nor accessed by the customers. Okay? They are only accessible via SQL. Okay, that's what. Okay, whatever the data is available, right? Okay, as I told, right, this database, okay, actual data where it will store S3, right? Okay, I want access this data mean ideally I should come, okay, uh, with the SQL query only. Okay, I need to trigger respective SQL query. Okay, the query will bring data, okay, from this database, and give back. Okay. So while loading the data, Snowflake convert them into optimized columnar compressed format. Okay, as I explained, right, what is a columnar format? Okay, this columnar is Snowflake proprietary one. Okay, so it will add advantage if you store the data in columnar format. Means whenever you do column level operations, you're applying on the any like operations on the column only. Okay, at the time it will query will give more efficient, okay, result. Okay, like salary is a column, I want to do average on column. Okay, we have marks, okay, column. Okay, you want to calculate percentage. Okay, why all your marks will store at one place, right? As I told, corner means columnar format means like marks, like subject Telugu is 90. Okay, marks, how it will store? Okay, let me keep here. Marks will store like this, right? Columnar means 90 Telugu. Let me keep first subject. We have two columns, subject and marks. Subject first is Telugu, second English, third Hindi, next science, okay, next social, next math. Okay, assume mark how it will store 19, assume 80. Sorry, yes, see how data will store. Like this, right? So I want to do average. Okay, so I can do very easily. Okay, base marks, right? Marks average. Okay, I will take all this data from this column, marks column. You can do average. Okay, I want to do total. Easily I can do. Okay, here this is a small data. Assume if you have big data like uh, in the e-commerce, right? Okay, so sales related. Okay, we have measures, right? Okay, quantity. Okay, and the price related. Okay, so if you are applying, okay, any operations, okay, on top of those column, okay, the query efficiency will be more. Okay, why? As data is storing like this. Okay, so these are the basic points with respect to, okay, not so basic, so total complete points, okay, we discussed, okay, regarding the Snowflake architecture. Okay, so with respect to all these three layers, right? Okay, so if you have any doubts, okay, make a note, Okay. So few topics we need to cover. Then only you can understand. Okay. Whatever I learned, right? Here, see, Snowflake, task, materialize view. Okay. These are separate topics. Okay. Which we need to discuss. Okay. Then only you can understand. Okay. Exactly. Okay. So for those, right? Hold on. Okay. We have separate session. Okay. Now, apart from that, okay, if you are not able to understand anything, please, okay, you can send out a mail. Okay, I will try to okay explain in any separate video for those points. Okay, so each point I repeated multiple times. Why? Because this is very very important. That's why even 1 hour also I didn't stop. I didn't cut it this video. Okay, this is very very important. You need to understand each point. Okay, still I believe you will get some doubts. Definitely. Okay. So please send out a mail. Okay. I will try to okay revisit if any points I missing. Okay. So that's all for this video. Okay. Thank you.